Well, students, I'm going to give you part 2 photoelectric effect explanations, the observations which have been made by the great scientist Sir Albert Einstein. Students, I'm going to discuss with you the original graph put forward by Sir Albert Einstein. But before I start lecture, I advise you that you should bring one notebook and you simultaneously sketch the graph. See students, this portion is the experimental arrangement, and here I'll explain the graph. So what I do is I'll explain this graph. Since मेरे पास I have a limitation, so I will explain this graph 1, then rub it, then I'll explain the second graph, then rub it, then third graph, then rub it. You should do one thing. You should simultaneously note down. First understand, then pause, then note down, right? So let's start. The first graph, how it has been obtained by Sir Albert Einstein. He has kept the intensity of the incident radiation variable. Intensity of the incident radiation variable. You will put one question, sir, what is intensity? Intensity of light. You just see the light is falling on me, right? The light is falling on me. What is intensity? Is the light received per unit area, per unit time, when the area is held perpendicular in the path of the light. For example, if just a minute, if I have this CD with me, right, this compact disc. On this CD, the light is falling. See, if the CD is held perpendicular, CD is held perpendicular, the light energy received per unit area, per unit time, the light energy received per unit area, per unit time, when the area being held perpendicular on the path of the light, that is called intensity. Again, intensity is what? The light energy. Light energy. E received per unit area, per unit time. Energy per unit time, watt upon meter square. आगे क्या है? Just listen. Area being held perpendicular. Area being held perpendicular. So that is called intensity. Clear? Now, light is made incident here. Light is made incident here. By opening the window, there is a window. By opening the window, we can increase the intensity of light. When we increase the intensity of light, what do we find? The current is increasing. Which current? Photoelectric current. Interesting. What is kept constant? The frequency. Now we'll put a question. Sir, how frequency? Look students, if we fix the frequency by fixing the color of the light, then we keep also the retarding potential constant. You will put a question, students, what is retarding potential? With the help of this potential dividing arrangement, we can keep the retarding potential constant. Already in the previous lecture I have explained retarding potential. No, I'll explain in Hindi simultaneously. हम लोग लाइट की इंटेंसिटी को कांस्टेंट रखेंगे, लाइट की इंटेंसिटी को वेरिएबल करेंगे, तो जो करंट है वो वेरी करेगा. करेक्ट? We increase intensity, current increases, right? तो current is proportional to intensity of light. हम लोग इंटेंसिटी को इंक्रीज करते जाएंगे और करंट भी इंक्रीज करता जाएगा, लेकिन फिक्स क्या रखेंगे? फ्रीक्वेंसी ऑफ लाइट और रिटार्डिंग पोटेंशियल। ये पहला ग्राफ है जो सर एल्बर्ट आइंस्टीन ने एक्सप्लेन किया। क्या? इंटेंसिटी इज प्रोपोर्शनल टू current is proportional to intensity. Current is proportional to intensity. What we keep fixed? Frequency as well as the retarding potential. Any doubt? So note it down. Agla graph. Next graph I am going to explain. So this lecture is in English. Hindi plus English. Combined करके बताऊंगा मैं।